Hey Sharks, this is Mr. O with your second set of vocab set notes. We just moved on from layers and plates. Now we're moving into soil and human impact on soil. Just like before, we're going to start with key vocab. Moving on, you're going to need your composition notebook, not your binder, your composition notebook. In your TOC, you're going to include number 5, which is soil key vocab. Remember, when you're going through these slides, you can always pause them, rewind them, look back over them when you come back to unit tests and quizzes. But this is for you as a tool and also a study tool, and these will be checked tomorrow in class. The format of each slide will look just like this for the most part. You're going to have the key vocab word up top, your definition on the left, and there's going to be an illustration to help point out the definition on the right. You're more than welcome just to write the vocab word and the definition, but if you want to include an illustration, I helped you do that. The first word is the pedosphere. I know it sounds weird, but the word ped actually means feet. Just like the atmosphere, the lithosphere, the asthenosphere, the pedosphere is the layer of the earth that people live on. Ped, feet, layer of the earth we live on. And this whole unit is about understanding soil, understanding how humans impact soil, and how valuable soil is as a resource for us. The next word is stewardship. Stewardship can be used in a lot of different ways. Essentially, you can be a good or bad steward of many different things, but in this unit, we're looking at about how you can harm or protect soil. That's why the picture shows how people who protect soil are good stewards and people who harm it are bad stewards. Before we get into anything else, there's 2 different tools that humans use to study the earth. These are very general tools and not just used for soil, but in the soil unit, we look at these 2 tools because people across the world use these to understand how the world is changing over a period of time. The first is remote sensing. If you can look at the picture, you can tell that the satellite is taking images of 1 or 2 different ways. You can either take direct satellite images right to the satellite, or using sun to bounce off the earth to record that image as well. But remote sensing, remote meaning not there, and sensing meaning imaging, so it's not there imaging. So we are able to take pictures from afar to learn about how our earth is changing over time. The second of which those systems are is called Geographic Information System, which is GIS. Don't confuse this with GPS. People use this in a lot of different ways. I like the picture that I use because it shows that GIS systems are used for streets or buildings or vegetation, which means plants. But then you're also able to put all those layers on top of each other. So people are able to study what's happening with the world, what's happening with the soil, how are trees and plants growing over a period of time, and how are the human impacts, meaning making buildings and streets, impacting those areas as well. The rock cycle. This should be nothing new to you. In short, rocks constantly change over the time, just like water. All the rocks that were in the world when the dinosaurs were here are the same rocks that are here today. The only difference is they can change form back and forth. They can change from a sedimentary to an igneous to a metamorphic over the course of time. We kind of studied this with layers of the earth when plates get pushed into the mantle and get melted, and then they get changed into another rock and they come out of a volcano. But just so you know, the rocks all do cycle around and change the form over the lifetime. Now, this is not a slow process like any process with rocks. We will look at weathering. One of the main ingredients to soil is broken down rock particles, and weathering will be the way that rocks are broken down. You need to know weathering. There's 2 types. There's mechanical and chemical weathering. The first of which is chemical weathering. This is done, if you can tell from the word, chemicals. Acid rain, oxidation, which means rust or dissolving. What I've shown you was a statue picture. You can tell that it's getting broken down and worn over time by acid rain. So rocks are able to be broken down via chemicals. The next is mechanical weathering. Mechanical actually means like mechanics, moving, forces, physical processes. I've shown a picture of ice wedging, which if you've seen a crack in a sidewalk and that sidewalk fills up with water, freezes over the winter, and then in the spring the sidewalks begin to crack. Tree roots can crack driveways and roads and rocks. Also in landscapes. Abrasion just means like physical force or rubbing or friction. And then pressure release is several different examples of mechanical weathering. Getting into soil now. First, we'll talk about soil profiles. Soil profiles is if I took a section of the earth, if I cut down straight to bedrock. And if you don't know, bedrock is actually the start of the crust. And you're able to analyze what the different layers are, or horizons. And you can see in my picture that this picture has an A horizon, a B horizon, a C horizon, and where you see bedrock is the start of the crust. Now, depending on where you live in the world, soil profiles will change. The next is the horizon. Soil horizons is also known as soil layers. There are 4 possible soil horizons, but a few of them are not soil. So the first is O layer, which is not soil, but it's the organic matter that lays on top of the soil. The first soil, the second soil, and the third soil layer are A, B, and C. A being the richest, B being where like big tree roots grow, and C meaning where big rocks that are not broken down decide to rest. Now, depending on where you live, the profiles will be different, and some profiles have an A, B, C, some have a B and C, some have an A and B. It just depends on where you are and what the climate is. We will be relating this to biomes, which you learned in last 3rd, 4th, and 5th grade. The next is an ingredient of soil. Most ingredients of soil are pretty straightforward. Rock particles, nutrients, minerals, water, air, but the one that will not be as common to you is called humus. Now, humus, don't be confused with hummus. Hummus is what you eat with pita chips. Humus, however, is broken down organic matter. It's leaves, plants, and they're all decomposed, and I wrote decamped, and it's actually decomposed by microorganisms. So in that definition, decamped means decomposed. Microorganisms are the things that will break down and make nutrients for soil. Microorganisms, even though they're gross, they're very small things. Fungus, bacteria, algae, mushrooms, all these different types. These animals and little things are really good for soil because they actually bring nutrients to the soil. Plants, just like humans, need nutrients to grow and survive, and microorganisms provide that. General word, properties. In short, it's things used to describe an object. Properties is very general. We'll be using it in several different units. This is the first of which you'll see it, but you'll see it in matter and waves as well. The first is a soil property of texture. This simply means how something feels. So if you took soil and you rubbed it through your hands, is it rough? Is it soft? Is it sticky? Is it hard? All these things are texture, and they can tell you a lot about what's in the soil and how the soil is. The next soil property is color. Obviously, color is what it is, but color lets you know a lot about how the soil is. In North Carolina, we have red soil because we have red clay. Depending on where you are, if the darker the soil, the more nutrients it has. The lighter the soil, the less nutrients it has. So color is a very important, even though it's obvious, property of soil. Pore space is a little bit more confusing. It's about talking about the pieces of the soil and how close those pieces are. And pore space directly relates to water retention. If you think about it, if you put a bucket of water on sand, it will run right through it. But if you put a bucket of water on clay, it will not run right through it, and the water will stay in there because the particles are smaller. You can see from the picture I have 4 different examples and how long it would take for a bucket of water to get through them, and you can tell that clay would hold the water way faster than gravel or sand would. Chemistry is the last property of soil that we're going to talk about. It's actually the pH of soil. Soil can be acidic or it can be alkaline. Alkaline means basic. And plants like to be near neutral. You can see in my chart, if it's too acidic, it's bad for plants. If it's too basic, it's bad for plants. So farmers and people have to understand that chemistry in soil can help why things are growing or why things are not growing. Acid rain and other things can change soil too, so that can also mess with chemistry. Plant and vegetative cover. These literally are plants covering the surface of the earth. I showed you a picture of this hillside with these big trees, and these big trees with plants that have roots. And what the roots do is actually keep the soil in place to prevent against wind blowing the soil away or rain running down that hill and taking the soil with it. If you remove the trees, then wind and rain will be able to move that soil, which is harmful because the soil will be displaced into streams and rivers and other things like that. In general, the next thing is soil conservation. This is how people can help keep soil healthy, and this is ways humans can actively try to protect soil. And a lot of these are based on farming practices. The first of which is crop rotation. It's rotating crops into different fields because if you keep planting the same thing in the same spot, you're going to strip the ground of all the healthy nutrients. Crop rotation allows for different plants to be grown there so different nutrients can be taken and added back into the soil over the growing seasons. The second is conservation tillage or conservation plowing. This is a way farmers don't plow as much as they should. I showed a picture of this corn here, and they leave a lot of the stuff behind to cover the ground and let nutrients get back in. Now, some people would over farm and overtake all that ground, exposing the soil, which could lead to bad things. So conservation means less, and less plowing or tillage is beneficial to soil. The next is terraces. This, if you can see from the picture, are like steps going down a mountainside. This allows people to grow on steep slopes. Now, if these steps were not made, water and wind erosion would take over. For example, if that water rained on a hill, the water would all run downhill, but on those steps, it allows for the soil not to be lost. Contour plowing is the next, and contour plowing is very similar to terraces. It's planting groove-like things. It leads to preventing soil to be lost from wind and rain. This is also done on slopes. So often we'll say, if you had a slopy land, what can you do to protect soil? And the two answers would be terraces and contour plowing. Windbreaks are the way of planting trees in between open crop fields. If you think about the Midwest, when you have big open areas and the wind blows, all that dirt goes everywhere, the seeds go everywhere. But if you allow for these walls of trees to be built, it prevents the soil from being hit by the wind as much as it could be, and allowing the soil to stay in place and keeping the nutrients in there. In general, there are 3 ways humans harm soil, and we're going to get more into these when we get into this part of the unit. Soil takes hundreds of thousands of years to become healthy again. So if you ruin soil in your lifetime, you will not have healthy soil again. The most common ways humans harm soil are by farming practices, mining practices, and construction development. All 3 of these can affect soil's nutrients and add pollution to the soil, and also you can create opportunities for soil to be lost by wind and rain beyond natural measures. So that's the end of this flip notes. You need to have these in your composition notebook. I will be checking these in class tomorrow, and you will have a quiz on these in about a week and a half. Remember, pause, rewind, go back. It's the benefit of flip notes.